Hello, let us start electrostatic potential. We have studied about the electrical intensity and its behavior in different type of things like in metal, then in non-metal or else dielectric. Okay, and how does it behaves with a charge? Okay, so that's all we have studied, and now we have applied even Gauss's theorem to find the electric potential instead of scattered charges. Now we will study about the electrostatic potential energy. Clear? So how does it comes? So when we apply a electric field, suppose E, this is the electric field we are applying on a specific space, okay, in an area. So this is electrical field E we are applying. How we can apply electrical field? By keeping the positive end of the battery at this end on the plate, we get the electric field. Okay, so in this field, if we are keeping a charge Q, so according to the nature of this charge, suppose if it is minus, then it will be attracted towards this end, away from the lines of the electric field, because it is minus and this side is positive. And if it is plus, then it will be deflected from here, correct? So according to the nature of the charge, it will be either given a force at this side or this side. So it will be doing some work. So how we can write Q into E, that is equal to the force that we have already done it. So now F dot dr, suppose we are writing, so this gives the work W, that is equal to the energy U, or else we can write it as V. So what we can write, that E dot dr, that is equal to E dot dr, we are writing is equal to the V. So if we are changing a small distance from here, so there will be change in potential, so that will be writing as dV. So this is, we are doing work against the force, so we will be writing minus. So what will be writing, dV by dr, that is equal to minus E. So we write dV equals to E dot dr. This is one way we can deduce the potential energy, and we can get a relation between the potential energy and dr. Now suppose we have taken a charge Q, so where the energy and this, suppose if this dV is 0, so this is constant. So what happens, that electrical field is inversely proportional as the distance x or r. So electrostatic field at a very small distance will be very large, correct? At this very distance, at very close, where x is very low, electrostatic field is very high. So we'll be getting the concentrated lines of force from the charge. But when it is going at a far away distance, this is getting highly paced, like this will be in this way, okay? This is getting highly paced. So this is the explanation of the electrostatic fields and dV. Now we can deduce these things in some other way also. Suppose we are taking F, the force we are applying on a charge, and this is dr, we are taking the distance. So F dot dr, that is equal to dW, or else we can write dV. Clear? So in this way we can even derive, we can take the Coulomb's law, 1 by 4 pi epsilon into dr. Okay, so this 1 by 4 pi epsilon into 1 by r square into dr, and here there is a charge, we are writing Q1 and Q2. Let us write it Q1 Q2 1 by 4 pi epsilon 0, and this is r square and into dr. So these things will be finding out the, in this way we'll be integrating it and we'll be finding the potential. So we'll be writing dV, that is equal to this quantity 1 by 4 pi epsilon Q1 Q2 by r square into dr. So we'll integrate here and we'll integrate here at this position. So this integration from 0 to V, and this integration will be doing from infinity to r, because at infinity the potential is 0. Clear? So at a large distance, hence we'll be writing like this 1 by 4 pi epsilon, and we'll be integrating these things and we'll get Q1 Q2 by r. Okay, this one will be writing in this way and we'll get minus, because you know r to the power minus 2 into dr, that gives 1 by r minus r. So this one minus 2 plus 1, and here down this will be minus 2 plus 1, so we will be getting 1 by r. This we can integrate and find out. So 1 by 4 pi epsilon will be getting q1 q2 by r. Clear? Now suppose we are taking a charge from infinity to a distance x. In this case we have taken at infinity, suppose a large distance, this is in electric field is 0 here. So what happened, we are bringing the charge from here to this end. So we'll be doing some work here. No, how it is possible, you see, we can show it by a magnet also. Okay, suppose we have taken a magnet and this is a magnet. This is almost like a charge, and if you are giving a force here, so this magnet is getting away from here, so it is giving a force on this charge, so it is doing some work. See, this magnet is also doing some work, it is not a human, so it is doing a work here. Similarly, a charge is also doing a work. If we are taking a opposite sides like this, if you are taking like this, so it will be attracted even in some cases. Suppose if similar poles are taken, then it will be attracted here, otherwise it will be deflected in this way. So in this chart what happened, we will be writing here, so this is 1 by 4 pi epsilon, and we'll put these values here and we'll get q1 q2 by x. So this is the potential V. Okay, so in this way we can find the potential. Now in this way, if you are taking q equals to 1 unit charge, positive unit charge, so what will be getting, will be getting 1 by 4 pi epsilon, that is q by r, q by x. Okay, this q we can take q1 as q and we can write like this. Now how will be defining the potential energy, that I have already told you in class 10 also, that potential energy is when we are bringing work done to bring a unit positive charge from infinity to this point. So this we are writing like this. So what we have learned now, we have learned that dv by dr or else dx, whatever it may be, so that is equal to minus e. This one we have learned, which comes in CBSE very often, and this prove that is the V potential, that is equal to 1 by 4 pi epsilon minus q by x. This is same like gravitational field. Okay, so these two things you should always remember, and now we'll be solving some CBSE questions which comes very often. Okay, so let us try this one. So here it is given that one question, that is, name the physical quantity whose unit is joule per coulomb. Joule per coulomb means W by Q. So this one we can find that this is equal to E, Q into E equals to W. So in this way we can find out the joules per coulomb, that is what is the physical quantity. Okay, in this way we can solve this one, and next one will be doing a long questions of CBSE, that is coming sometime, that is a potential due to a short dipole at a general point is given by V equals to 1 by 4 pi epsilon P cos theta by r square, and in this equation, from this equation find the corresponding expression for the electric field. Clear? These two things we can do from this chart. So we have got, suppose, a dipole here. What is dipole? I explained you earlier also. A atom is a dipole, or else a magnet is a dipole having two pole equal and opposite charges. So let us take minus q here and plus q here. It is separated by a distance L and L. So let us find a point at P. Okay, at P we are taking this point. So now from the P we take this distance as AP. Okay, and this distance will be BP. Clear? So this will be a longer distance and this is a shorter distance. You see, this is a longer distance AP, and BP, this is a shorter distance. So what we'll be doing, we'll be drawing a line from the midpoint. Here it is the midpoint of the dipole. and we'll be drawing a line in this way and we'll extend it here, okay, and we'll draw a perpendicular. So this line and this line will be equal to each other, so you can draw it yourselves and can see it. So another thing I am telling, we can take P from B, we can connect it like this and draw a perpendicular from B to this point. So this portion and this portion means this distance and this distance will be almost equal. So in this way we can draw a line and let this be theta, okay, and this is also theta, and this is 90 degree, this is also 90 degree. So what we can write? We can write the potential. We'll be deriving, we'll be answering this question now, okay. Now in CBSE they are giving part by part marks. So if it is having 3 marks, so how the first marks is allotted for this? Suppose will be writing potential at a point for minus q. For this point you will be writing exactly like as it is given V1, the potential due to this, let us say V1. So this V1 is 1 by 4 pi epsilon. This is we are writing here, we have taken a unit positive charge and it is minus q by AP. Okay, this is AP is the distance. Now next we will be finding another thing, that is V2. V2, the potential is equal to the 1 by 4 pi epsilon, that is plus q by, here it is BP. Okay, BP is the distance. So this is one part and this is another part. Now next we will be adding potential. This is a scalar quantity V1 plus V2. So what we will be doing? We will be doing 4 pi epsilon, we will take like this and we will be writing minus q by AP, and here we will be writing 1 by 4 pi epsilon and q by BP. Okay, so now we will be taking 1 by 4 pi epsilon out and we will be writing, that is q will be taking here, and it is coming 1 by AP and minus, this is minus, so this will be minus and minus, will be taking here the minus out. So we will be taking minus out, means this is minus, this is 1 by BP. Clear? So this one, the quantity we are getting here. Now we will be deducting this. From this diagram we can say that this particular point, that is this is the total point, this distance is r. Okay, this is at a distance r from P to O. So we will be writing P to O, this is equal to r. So this we have elongated up to this point. So let us take, this is x and this is y. So it is elongated by bx. So what will be writing? Bx here. Bx is L cos theta. You just see this is 90, this is theta. So it is L cos theta. Here we are taking by. So by, that is also L cos theta. So we'll be deducting from, in order to get AP, we'll be writing from R, we'll be deducting what? L cos theta. So we'll be getting this one, because R is this much and L cos theta is this much, correct? This is L cos theta. So we'll be writing L cos theta, and this is we'll be getting for BP, not AP. It is we are getting for BP, and for AP we'll be getting R plus L cos theta. Okay, this will be minus and this is plus. I told you how cos theta is coming, L cos theta. L is the length, half length of the dipole. So L plus L becoming 2L. We are generally taking 2L. So what we can write? Q into this 2L, that is equal to P, dipole moment. So by substituting these values, 1 by 4 pi epsilon and here Q, and we are writing 1 by L minus L cos theta plus 1 by L R plus L cos theta. This one will be simplifying and we'll get, you just do it yourself and we'll get the same result, Q divided by 2L. Okay, here R and R will cancel each other if we are getting here and there, and in this case A plus B and A minus B, so it become R square minus L square cos square theta. Clear? This is the equation we are getting. Now we are simplifying it, and will be getting, so this one will be L cos theta. So here there will be a cos theta. So this one we are writing, and now we are writing the 4 pi epsilon, that is Q into 2L, one quantity, and cos theta divided by R square minus L square cos square theta. Now how we will be taking these things? L is generally the length of the dipole. Suppose we have taken an atom where this distance is 10 to the power minus 12 meter. Okay, so it's very small distance, that's why we are neglecting L. Okay, we are neglecting, and this we are writing 1 by 4 pi epsilon, and we are writing Q into 2L gives the P. So we are writing here P cos theta divided by, as we are writing, this one will be R square, as we are neglecting L square. So this will be the value of the dipole. Okay, so potential at any point. So we can write 1 by 4 pi epsilon, this is P dot R, and here R cube. Okay, in this way we can do the we can show it in a vector form. This is a dot product, so this is a scalar quantity that we have done earlier in class 11. So this is P dot R cube. Now we can find out these values. Suppose we will be taking V at a point, a potential at a point where theta is equal to 0. So if theta is equal to 0, so it will be, this is a radius vector and this is the angle theta. So what happened? So it is becoming 0. So it's becoming 0 means it's coming at this point. So we'll be taking at axial point. If we are taking, then cos theta equals to 1. Hence we'll be giving these values. But if we are taking an equatorial point, suppose this is an equatorial point at this point. So equatorial point, this is at 90 degree. So cos theta is 90 degree means cos 90 degree, this is 0. So at this point it will be 0. So potential at this point will be 0 and potential at this axial point will be having the values of this. Clear it is? Cos theta is 1, so we will be writing P here. So it is P by R cube and 1 by 4 pi epsilon. This is, I am writing once again, this will be P by R square, here we have written, and 1 by 4 pi epsilon. This will be the value at the axial point, and value at the equatorial point will be 0. So it is clear to you. Now from these specific things we can even find out the electrical field, and we can find electrical field as we have derived, that is E equals to minus dV by dr. Clear? So we can write the dV by dr means we are writing. Now student, we have got suppose 3 marks here. So 1 marks will be given for this V1 and V2 that we have derived, and for the expression of BP and QP. Now second marks will be on this V1 and V2 we are adding, and it is a scalar product that you'll have to mention like this. Okay, so we'll be writing here this, and we'll be making the expression for this. So second 1 you are getting here, 1 marks you are getting here, and 1 marks you are getting for the final results like this. So if you are correct up to this point, you will be getting 2 marks, and if you are doing after that this and arriving at this specific equation, you will be getting 3 points. So like this 3 marks is given. Clear? Now let us do another things, which is like this one. So find the electric field from that expression. So what we'll be writing? We'll be writing that E equals to dV by dr. So we'll be getting that value ER, that is equal to minus dV by dr. Okay, dV by dr means we'll be taking here, we are taking the position at this point, and if we are turning this radius vector, suppose this is a radius vector of this dipole, if we are turning at an angle of theta, so what happens, this is also getting elongated here dl, and this is also changing by theta. So change is taking in this vector by two way, one along the dl and another along the theta. So along theta it is extending like this and dl also extending like this. So we'll be getting two expression for the electric field. So we'll be getting ER, that is equals to minus dV by dr, and we'll take the minus d by dr, and the expression for the electric field, that is coming P cos theta divided by 4 pi epsilon by r square. This one, while we'll be differentiating, it is theta will be remaining constant here, so we'll be getting 2p what cos theta, 2p cos theta divided by 4 pi r cube. Okay, so by this one we'll be getting this value, and now next we'll be taking of another component, that is theta. So when we are taking the theta, so we'll be writing it like this. Suppose we are taking the changes along theta, so we'll be writing dv by dl. So it will be coming dl, it will be coming 1 by r dv by d theta, why L into theta, that is equal to r. So in this way we will be writing this equation. Clear? So as we are writing it, so we will be writing next, that is dl equals to, how we are writing, r into d theta. So this one we will be writing r into d theta. L equals to r into d theta. From the figure you can make out, this is dl, this is the r. So equals to r into d theta equals to dl. So will be dl equals to r into d theta. From this we will be writing this expression. So next we will be writing how we are getting this one. So by differentiating we get 1 by r, we keep as it is, then dd theta of, we are taking p cos theta divided by 4 pi epsilon, will write like this, divided by r cube. Clear? We will be writing like this, r square it is, so we will be writing like this, because it is in scalar form now we have kept. If it is vector form, it will come r cube. So this one, when we are computing, we will be getting E1 equals to p sin theta, cos theta by differentiation comes sin theta, and this will be coming 4 pi epsilon r square. Okay, so this is r square as it is we are writing. Now the total electric field E will be the vector sum of ER and E theta. So it will be like this, E square